Well, good evening. I'm Charles Schultz, and this is the Randomizer. And today we're going to be discussing something in the biochemistry realm, and it's the human growth hormone, HGH. There's a lot to be said about human growth hormones and hormones in general, and we're going to talk about that a little bit and how molecules can act as messages to living organisms. And also, I'd like to direct everybody to go to schultzlaboratories.com or universesciencecenter.com. Visit our facility in the virtual space, see our galleries, our exhibits, and interact with things. It's a lot of fun, it's very informative, and we're adding new material all the time. Become a member of Schultz Laboratories and support our development. And, visit our Patreon site. When you go to the Universe Science Center page, you'll see the link to Patreon. Make a donation, become a member, or support us in some other way. Join us 6 p.m. every weekday Eastern Standard Time for the Randomizer, where we pick a random technical term, and these technical terms are discussed in detail. Also, 9 p.m. Eastern Standard Time on Mondays, we have our robotics classes, which are in progress right now. Join us for that. It's a lot of fun. You'll learn some interesting things. So, if you also want to teach, get in contact with us. We'll set you up with a virtual gallery or some place to display your works, and a virtual classroom so you can share what you know, share your knowledge and expertise with other people. Well, let's get right into the subject of human growth hormone. So this is a fascinating subject. So a lot of people are familiar with the fact that a body has to have control systems. Any organism, any living thing, whether it's even a plant, an animal, whatever, it has to have a system of control that regulates its growth, its development, how it operates, how it responds to stress, how it heals. This control system in the human body is called the endocrine system. And the endocrine system is a complex network of glands and organs that release specific chemicals, control chemicals, into the bloodstream. Now, hormones are a little bit different from some of the other chemicals. Everybody knows when you're confronted with stress, adrenaline is one of the materials that your adrenal glands, which are located atop the kidneys, will inject into your bloodstream, and it will make your pulse race, your hands sweat, your blood pressure goes up, your alertness factor goes up. There's like a big jolt of caffeine and a lot of nervousness on top of it. This is a quick-acting compound. So adrenaline is one of those things that controls your fight or flight response, but it happens for a brief period of time, and use of adrenaline or the stress involved in adrenaline for a long period of time can actually be very damaging to your health eventually. But what we're looking at is something a little more, let's call it sedate. Human growth hormone has a technical name, and it's called somatotropin. And what it does, and it's released incidentally by the pituitary gland, which is up inside one of the most primitive parts of the human brain. The somatotropin, the growth hormone, regulates a number of factors in the human body. One, obviously, of course, is growth. Obviously, when you're growing, relations between the different parts of your body as you grow will change. Your limbs, your balance, everything changes slowly as your limbs extend in length. Children have a proportionally large head compared to the rest of their body. And when they stumble, they have to react very quickly. Adults, on the other hand, are very tall and they take longer to fall, and we can act in a more sedate manner sometimes. But our balance points are different. And so, over a period of years, you learn how to coordinate as you're growing. We all tend to go through a clumsy phase somewhere in the middle. The key here is hormones are slow acting. And somatotropin, or human growth hormone, regulates the growth of your tissue, the length of your limbs. It regulates also healing responses to some stressful things such as being damaged or cut or injured. And it is what's known as a polypeptide hormone. It is 191 amino acids in a string like a necklace, little beads on a chain. Now, an interesting thing about polypeptides, proteins actually, is that when they are produced in the cells, there is an element in the cell that acts as a factory that takes the instructions in the sequence of genetic code letters A strand of genetic material goes into this 3D printer that makes proteins. And so this is called the ribosome. And ribosomes are one of the most important elements of your cell. Like I said, they act like a 3D printer. So a piece of genetic material goes in, the ribosome reads 3 letters at a time, and each time it gets 3 letters, a specific protein sub-element called an amino acid gets clicked on to the string. And as the next triplet goes in, the next protein growth occurs, the next little amino acid gets put on the string, and this long string of amino acids is ejected by the ribosome. When it is ejected, it begins to fold up in some complex manner. And this is one of the most difficult problems in biology, mathematically speaking. How do proteins fold properly? So the protein folding problem actually has been solved now using artificial intelligence methods. But this one particular protein, this somatotropin, is the one that when it's folded up and then injected into your circulatory system regulates that growth. Now in times past, there were some maladies that were treated with somatotropin, and one of them was if a child came from a family where shortness or dwarfism was common, it was often prescribed to help combat the signs of it, to make you grow taller. In some cases, if there's a problem with the pituitary gland, it will cause undue growth. And the best known example of this in my mind is Robert Wadlow, who grew to be nearly 9 feet tall due to an issue with his pituitary gland. Now, a lot of things can also happen in response to human growth hormone, and one of them is it can actually help you develop a little more tissue or a little more tissue mass than you normally would. And athletes used to dope with human growth hormone years ago. And there's a very simple reason for this. This hormone is normally metabolized by the body in such a way that it does not leave a signature in the urine. So it was not detectable when it was being used. Now they have other methods and they can detect it. But it's something you have to take for a period of time. It's not like a steroid. Steroids are a slightly different class of compounds than hormones. And what happens with these is they regulate things in your body a little bit differently. A steroid can cause localized growth or localized responses to certain things. And stop and think about this for a moment. We're talking about molecules and molecules that act like messengers. When you really look at it, one of the things you'll discover is that every molecule that exists can act as a messenger to living tissue. Now, in many cases, the cells don't respond to the molecules in any specific manner. But in some cases, certain molecules can trigger changes in the cell's function, and as a result, changes in the growth of tissue or the response of the body. So again, hormones are slow, moderate acting compounds that exist in the body for a period of usually months or years at a time. And they moderate your metabolism, by the way, as well, or as well as your growth, which we mentioned, and the ability to heal. The moderation of the metabolism, some hormones will change how you get energy from your food or from fat stored in your body. The other thing to consider is that growth disorders are not the only signs of a hormone disorder. You will often have other things happen that take months or years to show up. And by the way, puberty and maturity is also controlled by hormones. So your body has a schedule. And during certain periods of your life, it will switch production on or off from various glands in your body. And sometimes some glands will vanish entirely. There's a gland called the thymus gland that is present in very young animals and young humans. But by the time you're 11, 12, 13, the thymus gland literally vanishes. And many people were very curious about this early on because they felt that in the work of gerontology, which is the discovery of how aging works and how you might treat it, they felt that the thymus gland was one of the prime regulators of your youth. Now, they have learned a lot of things about the body and how it ages by studying the thymus gland, but it isn't the cure-all that they thought it might be. There was a period of time where they actually took thymus gland hormones and injected them in people to see if it would return them to youth. Now, recently they have discovered that there are compounds that destroy senescent cells. There are basically three types of cells in your body. One's called senescent cells are the ones that are old. They've reached the end of their life. Then you have juvenescent cells, which are the ones that have the ability to divide, grow, and replace damaged tissue or repair it. And then you have cancer cells. And believe it or not, I might have mentioned this before. At some point in your life, you probably did have cancer, but cancerous cells are one of the things that your body recognizes and tends to destroy. So your body has a mechanism to locate and weed out and destroy cancerous tissue under most circumstances. Not a lot of times people feel it is a miracle when they go into remission, but it's generally considered to be a normal part of your body's function. It really depends on the type of damage and how much damage there is. Your body has a switch built into every cell that when it recognizes a certain threshold of genetic damage has occurred, it turns off the power to the cell, the mitochondria. It switches them off. Once this happens, the cell blebs to death. It breaks up into little bubbles and destroys itself in a process called apoptosis. So you are constantly, your system is constantly patrolling for damaged cells and trying to get rid of them. So now, this new treatment for aging learned a lot from hormones and hormone therapy, but they now have a compound which they put into the body that locates and destroys a small fraction of the senescent cells. So juvenescent cells, as I mentioned, can split, they can grow, they can repair damage, and continue to do so. But your cells have a limited number of divisions built into them. It's just in the nature of things. When cells reach the end of their life, it was thought that they just simply acted as placeholders. They would just live and be tissue. But one of the things that has recently been discovered is juvenescent cells have a completely different profile of action than a senescent cell. A senescent cell actually often produces toxins. By removing a fraction of the senescent cells in your body, youth is returned to some degree. Now, one of the things we did learn how to do was to get rid of the limit of cell divisions. The telomeres in the cells, which are the handles that pull the gene clusters apart when the cell is replicating, when it's duplicating itself, those telomeres get shorter and shorter, and this determines how many divisions a cell can undergo before it dies or quits dividing, becomes senescent. Telomerase, a hormone that your cells actually have a program to produce, is a compound that adds extra protein subunits onto the telomeres, allowing the cell to divide more times. In cancerous cells, sometimes the gene to produce telomerase is activated, and this is why the tissue continues to develop and grow. It also turns on, often enough, capillary growth factor, which makes capillaries grow more abundantly, bringing a supply of food and oxygenated blood to the tumors. So tumors generally activate 2, 3, 4 different switches in the cell because of their damage, and this is what makes them become tumorous. But the removal of cancerous cells and senescent cells by the use of this new compound can literally make an organism younger again. And this is now undergoing human trials. It was done with mice, and they discovered that with an administration of this particular compound, which is very similar to a hormone, the mice got thicker, darker fur, they regained kidney function, they regained liver function, and they became more active. They began playing on the wheel, eating food, and interacting more often. So they literally made the mice younger. So in the near future, we're going to expect that this sort of treatment may become something that people can get at any clinic. And that sounds like a very hopeful thing. You could live for a couple of 100 years with treatment like this, perhaps more. So hormones. Hormones are molecules produced by a system of glands and organs in your body entitled the endocrine system. And one of those hormones, somatotropin, was human growth hormone, is one of the ones that was most studied and used to treat early illnesses. And again, disorders with the pituitary gland can cause dwarfism or giantism. One of the things to keep in mind is when they help people to grow in height, sometimes the bone density isn't quite as good as it would normally be. And so there are other treatments that they are given as a countermeasure to help increase bone density. So, and the improper use of hormones, of course, can lead to incredible wrong growth, deformities, and other problems. So, they're one of those things that can be a tool and a weapon if you don't know what you're doing. So, I'm hoping that this is helpful and informative about hormones in general, and the fact that your body has a schedule during which it releases certain hormones in a sequence during the course of your life, and it knows what it's doing. It's been working very well for, well, I don't know, millions of years. So I hope that you've learned something, and the floor is open for questions. Meanwhile, I'm going to encourage you to go to the Universe Science Center or Schultz Laboratories, become a member, join our classes, learn something amazing, have fun with it. Bring your kids, put your 3D headset on, walk around and experience all the fun things that you can see. And by becoming a member, you support our growth, you support the addition of new interactive exhibits, and what can be wrong with that? So if anybody has any questions, we are open, and I don't see any statements. Oh, here we go. Yes, please go ahead.
Yes, this is Elizabeth. I do have a sort of a question and a statement.
Okay.
In my work, of course, with the introduction of hormones, a lot of times doctors have been, as you said, experimenting and throwing different kinds of hormones at folks, and not always to good advantage. Too much estrogen, too much testosterone,
right,
can cause all kinds of issues. And HGH is considered like a panacea of youth. And a lot of times people are taking precursors to HGH,
yes,
in the hopes that it will turn into HGH. What we found is it did not translate as well as they thought it would. Would you speak to that?
Okay, so yes, if you take a precursor compound, what that is it's a compound that can easily be converted into the expected target compound. Perfect example, eating carrots. Well, the orange color in carrots is a molecule called beta carotene, and strangely enough, it cleaves exactly into the center to become two active molecules that are considered good for your vision. And so eating beta carotene generally does lead to an increase in this particular vitamin that's good for your eyesight. But in taking hormone precursors, it doesn't always produce the compound you want because it can only be converted when your body is running the program to do that conversion. Your body can produce precursors of molecules and have them in the system, and then when a switch is thrown, they get converted into the compound or hormone that you're trying to get into the system. So, hormone therapy is one of those things that as a general rule these days, it's only resorted to as is kind of a last resort if they don't know what else to do, or if they know very specifically that will help in that case. So I'm going to say it isn't a panacea. It's something that has to be regulated very carefully. If you go online and you buy precursors for certain hormones, you're not always likely to get what you think in the end because it's not going to become the hormone unless your body is making the chemical that makes the switch over from that precursor compound that actually makes the extra step. And there are some compounds that do very specific things, and I'll name one of them is vasopressin. Vasopressin is one of those compounds that's released in your endocrine system, and what it does is it changes the fluid pressure in your vascular system, your bloodstream, and it causes you to excrete more moisture and dry out a little more. But that's a very well understood compound and one that is only given in specific cases. But yes, human growth hormone precursors don't always give you human growth hormone. So, your mileage may vary. If you're at a certain age, then it's more likely if you're younger, for instance, and not undergoing stress. But I don't have a full understanding of the endocrine system. I don't think anybody does. And I'm not a medical doctor, so I can't really give you any solid advice about it. I can only give you a general sort of advice. And a lot of this material can be found online. Now, I will tell you that. But again, take it with a grain of salt because you're going to be fighting through a handful of professionals and a number of people who actually are just trying to sell you something. And I have another one here. I just read another factor to aging is gene. Let me pop this message. Here we go. Okay, is gene mutation rate. Different animals have different gene mutation rates per year. Okay, now this is also true. But one of the things that happens is that if a cell's gene mutation rate is below a certain level or in a certain regime, generally as mentioned, your cells can repair some of those mutations. This is an interesting fact. Rate of cancer is typically thought to be related to environmental radiation. People who live at higher altitudes have less atmospheric shielding and actually do have a higher radiation exposure than people who live at sea level. Oddly, people who live in, for instance, Denver, which has a significantly higher rate of radiation from space affecting your tissue, have a lower rate of cancer. So the question is, why is that? And it's because a low level of constant irritation seems to keep your radiation damaging system on guard, and it seems to do a better job of sweeping up the damage. So that's just an interesting thing that has been learned. But yes, gene mutation rate per year definitely can have an effect on your aging, and people who have been exposed to doses of radiation in areas where it's very common can also age more rapidly. One thing in particular, living in or near a granite quarry or a mining area where there's plutonic rock that's solidified from beneath the ground, they generally have slightly higher background counts. If you live anywhere near a quarry and the background count reaches 80, 90, 100 counts per minute, get out of there. It's aging you, it's burning you up. It was recently pointed out by people who work in the nuclear industry that Grand Central Station in New York City, which is made almost entirely of granite, Grand Central Station, has a higher background radiation count by a factor of about 10 than is permissible in the control room of a nuclear power plant. So if you're in the control room of a nuclear power plant, you're getting only 10% of the radiation that you would get if you were standing in Grand Central Station from the granite and the natural minerals around you. So that's an interesting fact. I hope that's helpful. So very good. Any other questions? Any other comments? Floor is open. I don't see anything coming in. So at this point, I'm going to call it. So today's quote, surely he will never be shaken. The righteous will be in everlasting remembrance. And that's Psalms 112:6. All righty, guys. It's been a wonderful talk. I hope you enjoyed learning something about human growth hormone. And this is the randomizer for the 20th of April, 2022. I'm Charles Schultz, and I've really enjoyed talking to you tonight. Join us again real soon. We'll pick another one out of the hat, and we'll talk about that next time. Have a wonderful evening, and make the world a better place. Thank you. I'm Charles Schultz.